Third question, segment PM and segment PN are congruent chords of a circle with center C. Show that the ray PC is the bisector of angle NPM. Now they have given us here segment PM and segment PN are congruent chords of a circle. Now notice here, when they are saying segment PM and segment PN, they cannot be two chords which are away from each other. You can see that there is a common point of intersection of the two chords, which is P. That means when we are drawing the chords have to be touching each other, and that point of intersection of the two chords is P. So the far end of the chord, one end is M, the other end of the second chord is N. Therefore, segment PM and segment PN are congruent chords of the circle. Therefore, PM equal to PN. Okay, so it is marked by double line, both of them. They are saying that the circle is having the center C. So, I marked here center C here. This is the center of the circle. Show that the ray PC, that is, this is a ray PC. Okay, you see it is passing through PNC, therefore it is ray PC, is the bisector of angle NPM. Means we have to show that this ray PC divides this angle NPM into two equal parts. So if it is dividing into two equal parts, what should happen? Angle NPC should be equal to angle CPM. So what we will do is, anyway we have to show that these two angles are equal. So what we will do is, we will consider these two triangles. And if we try to show that these two triangles are congruent to each other, then we can say that angle NPC is congruent to angle CPM. And then therefore ray PC is the bisector of angle NPM. Now they are given only this much. We have a small construction. What is the construction? Which is done in dotted line. What is that? Join segment CM and segment CN. So I write join segment CM and segment CN. Now we consider in triangle CPM and triangle CPN. One is CPM, one is CPN. Now what happens? They have already given here segment PM is congruent to segment PN. So we write segment PM is congruent to segment PN, and that is given. Now further, we also see here that this segment CP or segment PC is a common side for both these triangles. So segment PC congruent to segment PC. This is a common segment, I said, or common side for both these triangles. So we will write here common side. So segment PC congruent to segment PC. Reason is common side. What about the third side now? We see that CM and CN is the third side. This CM is the radius of the circle because it begins with the center of the circle and drawn up to the circumference. CN also is the radius of the circle. It is beginning from the center and going up to the circumference. Therefore, segment CM congruent to segment CN because both of them are radii of the same circle. Now if all the three pairs of sides are congruent to each other in two triangles, therefore we can say that triangle CPM is congruent to triangle CPN. Therefore triangle CPM congruent to triangle CPN. Now by which test is this? Here also we considered side, here also side, and here also side. So all the three sides are under consideration. Therefore the two triangles are congruent to each other by the SSS test. I told you initially only when explaining this sum that if we prove that these two triangles are equal, then we can say that angle CPM is equal to angle CPN. So we write angle CPM congruent to angle CPN. And how are they congruent to each other? If two triangles are congruent to each other by some test, then the angles will be congruent to each other by CACT. And what is CACT? Corresponding angles of congruent triangles. So they are congruent to each other. Therefore, now we can write the last statement. What the question says: show that the ray PC is the bisector of angle NPM. Therefore, ray PC is the bisector of angle NPM.